our final conic, and the most complicated, is going to be the hyperbola. So what is a hyperbola? Well, before with all of our other conics, or at least with the circle and ellipse, we had a formula x squared plus y squared gave us some value. We'll say for the circle is r squared. That gave us one portion of the conic that was opening like this, and another portion of the conic that was opening like this, and they came together and closed up. They created this boundary. With a hyperbola, we're going to go the opposite direction. We're going to get an x squared minus y squared, or a y squared minus x squared, and that'll give us our, we'll say 1 in this case instead of r squared, and that will cause these conics to open in opposite directions, these parabolas. So that's why we're going to get a hyperbola. Hyper being too many parabolas to deal with here. So the first one we'll encounter will be a horizontal transverse axis. Well, what do I mean by transverse axis? Well, if I was to draw out a hyperbola, let's draw this. Got a bunch of asymptotes. We're going to get closer to there and there, and also here and say there. Right here, if I've got a vertex of one of the parabolas, a vertex of another parabola, this distance between, this is going to be our transverse axis. The other axis right here, we'll say right there, that's going to be our conjugate axis. We're going to be mostly working with our trans-axis, but similar to ellipses, we'll have a conjugate radii from the center of our graph to the edge of this conjugate axis will be a value of b, and the value between the center and this vertex is going to be a value a. We're finally also going to have to see that there's a foci in here, but different from our ellipses, which had the a value being larger than our c, you can see right here that now our foci, this value c, is much larger. So we're actually going to be able to go back to our original Pythagorean formula, which is a squared plus b squared equals c squared. Other than that, it's going to be very similar to the way that we approach ellipses. The one thing that I like to remember is that if this was a, let's say this was our xy Cartesian coordinate system, and this is a 0 right in there. There's no way, if I have an x squared, and this is just the way that I remember it personally, x squared minus y squared has to equal 1. Well, no matter what value I plug in for y here, y squared will always be positive. So there's no way that my x could ever be 0, because 0 minus a positive number will never give me a 1. So this value, this x squared, can never be 0, which means that x can never be 0. So if I had to compare which ones I was going to use, if I had the horizontal transverse axis opening left and right versus the vertical transverse axis, x cannot equal 0 here. X is 0 here. X is certainly 0 there. So For this one, we're going to open left and right. That's when our x squared minus y squared equals 1. This is x squared minus y squared equals 1. Because our x can't equal 0, and you can see x will never equal 0 for this graph. Our parabola, our hyperbolas will never get to this point right here. But for here, for this one down here, this is going to be our y squared minus x squared equals 1, because our y, this y, cannot equal 0. So the y will never equal 0. That's one way that's the algebraic way that I remember it. A visual way that you can remember that is that this sort of looks like an x, and this sort of looks like a y. So this means this would be an x squared minus y squared if it's opening left and right, and this would be a y squared minus x squared because it looks like a y when you open up. And they want you to draw that out in this situation. So I'll just draw this out really quickly, and you'll see that this will go to this asymptote. And I'm drawing closer to these because these are asymptotes. The graph will never actually cross these points. If this is our vertex, this is our vertex, this is our vertex, this is our vertex. This is our center. This will be our value for A. This will be our value for B. This will be our value for C. Now, how do I actually find these asymptotes? They're lines. So once I have a point at our center, we know that this is our point at our center. Doesn't a line, all I need is a point and I need slope. So if I can find the slope, I can identify what the line of this asymptote is. Well, isn't our slope rise over run? So don't we go up a value of A while we go over a value of B? So if we were to ask you about these slant asymptotes, it would be using the center point and the slope of A over B, where we went up A over B. Similarly, that's this slant asymptote right there, as opposed to this one right here, where we went down A. So the slope for this one is we went down A and over B. Transverse and conjugate axi of a hyperbola are shown below. They, again, just want to make sure that you understand that if my hyperbola goes like this, my transverse if he looks like this, this is my trans, and this is my conjugate. If I was to draw my parabola like this, I'm getting pretty sloppy, but I want you to just get the idea. Oops. This would be our trans, and this will be our conjugate. Identify our A, B, C, H, and K. It's a lot of stuff. So from here, we know this is an x minus y. So x minus y is going to look like an x, which means it's going to be opening like so. We know that our center, similar to an ellipse and all the other ones that we've done, all the other conics that we've done, our center is going to be at 2, -3. So that's right here. Our center is 2, -3. Our A value, and you can see that our A doesn't necessarily have to be the larger one anymore. Our A is just going to be our conjugate, or sorry, our transverse axis. So in this case, my A squared equals 9. That means that this value right here is going to be 3, because that's going to be our transverse axis radii, you can think of it as. Half of the transverse axis. That's our A value. Our B value is going to be the square root of 16, which will be 4. So if I was to ask you, what is my vertex? Well, I know that I start at a center of 2, -3. I've gone over 3, so it's 5, -3 for that right there. And this one I know has gone back 3, so it's 2 - 3, which would be -1, -3. The last thing you'll need to know for that is our foci. So I said here our foci is our C value, and remember that our C he's larger than our A and our B, so finally we're going back to C squared equals A squared plus B squared. Good old-fashioned Pythagoreans. So 4 squared, 16, 3 squared, 9, 16 plus 9 is 25. The square root of 25 is C squared equals 25. So our C is going to be a value of 5. So 5 from the center means that our focus should be 2 plus 5, which would be 7, and then -3. And this would be 2 minus 5, which is -3, -3. That's how we identify all of the points that we're looking for. All of the information that they're requesting of us. This is a y squared minus x squared, so y squared minus x squared. He looks like a y, so he's going to go up, but also down. Our center is going to be at the point. Remember that it's, even though we're mixing it up, we got to be careful that the x value is associated with the x and the y value is associated with the y. So this would be 1, -5. But our conjugate axis, sorry, our transverse axis, which is this one right here. Let's go a different color. Our transverse axis is the square root of 25, which is 5. Our conjugate axis is the square root of 4, which is 2. So let's put on all these points. If I went down 5, let's find our vertices. I went down 5. So my x value is exactly the same, it's 1. But it was -5, we're going to go down another 5 to -10. This one is still an x value of 1, but it goes up 5, so -5 plus 5 would be 0. The last thing I'll ask would be the foci. So where the heck is the foci? Well, isn't that going to be our C value? So a squared plus b squared equals c squared. 5 squared, 25. 2 squared, 4. 25 plus 4 is 29. C squared equals 29, so that means that C equals the square root of 29. So we know that it's going to be on this major axis, or this transverse axis, you could say, or we should say, actually. So I know that this point is going to be from the center. I'm going to go up square root of 29. So my x is unchanged, but it's going to be negative 5 plus the root of 29. This will be 1 because the x is unchanged, and then negative 5 minus the square root of 29. So again, find the center, find your transverse axis, your conjugate axis, and then finally you can find your foci using Pythagorean's theorem. This last part of the lesson we won't even cover, as long as you understand that your a squared plus b squared equals c squared, you can identify which is the y squared minus x squared, which is the x squared minus y squared, and plugging in all of your data so that you can find the remaining parts, you should be good.